Welcome to Sanford Flip Math. This is Algebra 2. We are talking about transformations. We are working in section 4.3 of the SpringBoard book, but this will correspond really to any book. This is just transformations with algebra. Basically, I need to hit some highlights here. I'm referring back to 4.3a and b. Just a reminder that anything that you are working with that's inside the function affects the function horizontally, which in other words means it's about x. And remember that inside means that what really happens on the graph is the inverse. Okay, I'm not going to spend my life on this stuff because it's already in the other videos, but okay, a reminder that if you have something outside of the parent function, it must be vertical, or in other words about y. And if it's outside, do what it says. So if it says +3 on the outside, then you're going up 3, etc. Okay, so whatever it says. Remember that addition and subtraction means that we're doing some kind of a slide, a move, a translation. It is not stretching or changing the shape. It's not flipping it upside down. It is just shifting it up, down, left, or right, just moving. Okay. If it is about multiplication or division, it is a scale change. So in other words, it's a stretch or a shrink. It's making things bigger or smaller. So if it's making things bigger, then something that's greater than 1, it means a stretch. If it's less than 1, it's a shrink. Okay, so we are not going to talk about a stretch of 1/2. That doesn't make sense. Okay, and if you do any multiplication or division by a negative, then that's a reflection, a flip. It's going somewhere else. Okay, so that's my recap. We're going to remind you of those as we need to, but my goals here are to identify the parent function. Okay, so the thing you want to look for is something key. So like for instance, the squared. This squared is not telling how a graph moves. This squared is telling you what the original function was. So the parent function is x squared. That is the stripped down version of the equation. It is as clean as it can get and still be the same shape. You see this squared here, and we know immediately that's a parabola. Okay, see that? So the parent function is y equals x squared. Okay, so I'm supposed to graph parent function and any transformations. Well, the parent function is y equals x squared. So I think I mentioned in other videos that the standard parabola, if I go right 1 and up 1 from the vertex, left 1 and up 1 from the vertex, I can go right 2 and up 4. This is kind of like a way to do quick point plotting without actually doing a table. So it's right 1, up 1, right 2, up 4. And really what what all that 2, 4 stuff is that idea that 0 squared is 0, 1 squared is 1, 2 squared is 4. And it is symmetric. Okay. All right, so we have identified the parent function. Okay, the clunking you hear is me playing with markers on the smartboard. Identify all transformations, so any changes to the graph. Okay, so I see an x plus 3 here. Okay, so the questions you need to ask yourself, are these on the, is that x plus 3 on the inside or outside? Well, that's inside. So if it's on the inside, it's horizontal, it's about x, and the next question is, what's going on? Well, this is addition, and remember that anything about addition or subtraction is a slide or shift or a translation, and it is inside, so I have to do inverse. Okay, so ultimately what that means is +3 inside the equation is really going to be left 3. Okay, so again, if it's inside, it's horizontal, it's about x, so it's right or left, or and then if it's addition or subtraction, then that means we're talking about a slide, and it's inverse, so the inverse of +3 would be -3. It's going to go left 3. Okay, so automatically I know it's going to shift left 3. This -2 is outside, so it's going to be about y. It's going to be vertical. And if it's outside, you do what it says. It says -2, so it's a translation, so it's going to go down 2. So what that means is every point on this graph, not down 2, sorry. Every point on this graph is going to go left 3 and down 2. So I'm going to start moving stuff. Okay, you ready? Here we go. I'm going to go left 3 and down 2. That's where the vertex went. I'm going to go left 3 and down 2. I'm going to go left 3 and down 2, etc. And I'm just going to sketch that off of those 3. I think 3 is enough. Okay? So left 3 and down 2. Now, I just want to take a quick look at that in the calculator. This is y equals x plus 3 squared. X plus 3 in parentheses squared, and I believe it was a minus 2. I will confirm that in one hot second. X plus 3 minus 2. X plus 3 minus 2. Okay, yep, we match. That's good. All right, I'm going to hit graph. Okay, there's my parent function, and here comes the other. And just to kind of confirm where I'm at, I'm on a decimal screen, Zoom decimal screen. And I just want to confirm that I'm at -3, -2 for the vertex. Let me do trace, change functions. -3, -2, there it is. All right, cool beans. Okay, so graph both the parent function and the transformed image. I did that. So those are the 3 things I needed to do. Identify the transformation. It moved left 3 and down 2. I graphed the parent function, and I graphed the new function, the transformed equation. Okay, all right, let's keep moving. All right, same instructions, just a different parent function. Okay, so this has square root in it, so y equals square root of x is the parent function. Okay, and we're going to do a little sketch of that bad boy. Okay, so it starts at 0, 0. Again, this is a graph of square root of x. This is the parent function. If I go right 1, I go up 1. If I go right 4, from 0, 0, that is, 4, 2 is on this graph. Okay, so this is the parent function, or you can label that P if you'd like. Okay, all right. Anything dealing with multiplication or division has to be done before anything dealing with addition or subtraction. Okay, this is a big deal. This is like a, please excuse my Aunt Sally issue. This is order of operations issue. Anything dealing with multiplication or division must be dealt with before any addition or subtraction. Okay, so I'm seeing this 2 out here and it's multiplying. Okay, so anything dealing with multiplication or division is a scale change, a stretch or a shrink. This 2 is on the outside. This 2 is connected by multiplication. Okay, so if it's on the outside, it's vertical, or it's about y. If it's multiplication, it's either a stretch or a shrink. Stretch or a shrink. And if it's on the outside, you do what it says. So in other words, I am multiplying the y values by 2. So this is a vertical stretch of 2. The only other number in the middle of this craziness is this x minus 4 inside the square root. Okay, so it's inside, meaning it's going to be about, it's going to be horizontal. It's going to be about x, and you do the inverse, inside inverse. It is subtraction, so that means it's going to be a move, a shift, a slide, a translation, and so the inverse of minus 4 is going to be plus 4. So this is a shift right of 4. Now, if that went too fast, you are in control of the pause and rewind and fast forward. Take your control. All right, so the stretch needs to happen first. Okay, so all I'm going to do is go through here, and I'm actually going to multiply every y value by 2. Multiply y by 2. 0 times 2 is 0. 1 times 2 is 2. So I'm looking at this point, and this y value is 1. This point has a y value of 2, so it's going to become 4. And nothing's happening with the x values yet. Now, what I'm going to do is I'm going to graph this dotted because this is after the vertical stretch. of 2, but I haven't done the move yet. I haven't made the switch yet to where it needs to land. Okay, so now I'm going to shift it right 4. So typically what I will do is anything dealing with a stretch or a shrink, I do first. And then I go and take that image and slide it. You don't have to do it that way. I will tell you that it works. I think it's the safest thing to do. Okay, so shift right 4. So I'm going to take this point on the red graph and move it 1, 2, 3, 4. I'm going to take this point on the red graph at 1, 2 and go 1, 2, 3, 4. I'm going to take this point on the red graph and go 1, 2, 3, 4. Now this is a lot nicer on graph paper. So this is my final image. Okay, so I need to label that somehow. I can do what I just did and write final. I'm going to recommend that when you do this, like on a test, then maybe you want a highlighter. And just make sure you're highlighting just your final answer. Don't highlight everything, because if you highlight everything, I'm not going to know what's going on. Okay, the point is to make a distinction. Okay, all right, so this was 2 times x minus 4. I'm going to pop in here and just take a, oop, that is hilarious. Why is that still on highlighter? Okay, let's clear the ink. Okay, and y equals, nope, still on highlighter. Clear ink and turn off. Okay. Okay, hopefully I'll still be able to write if I need to. All right, here we go. Clear, clear. Okay, so square root of x, I believe, was the parent function. I believe it was 2 times the square root of x minus 4. I will double check that before we get too excited about this. 2x minus 4. Awesome. All right, so the blue graph is the original. The red graph will be the new one. Something is not the right. Oh, no, that is right. There it is. Yeah, that looks right. All right, cool beans. Let me do a little bit of tracing on the second graph. Really, all I want to do is pop on over to, come on. It's not, I guess I should have done the value thing, huh? Oh, here we go. Awesome. I want to go to 5. Because 5 corresponds to, the 5 on this graph. Okay, so now I need to turn my Smart Ink back on. This thing is being finicky. There we go. Okay, this point, as you just see, is at 5, 2. It corresponds to the original point on the original graph of 1, 1. Okay, so let's just talk through this just for a hot second. I multiplied the y's by 2, so times 2. Sorry, I should probably use a dot for times 2. And I shifted it to the right 4. So 1 times 2, the y value times 2, is in fact the 2. And the 1 plus 4 is in fact the 5. So I'm just kind of checking that it really landed in the right spot by trying to track that specific point. Okay, I'd like to do one more. And so this is, I don't intend for this to be a long video, but I need you to see all the different stuff that can happen. Okay, and so just a quick little note here. If you choose to pop back here, just hit pause. This graph starts out going upside down because of the negative on the outside, and then it shifts 1, 2, 3, 4 left and 2 up. So it ends up looking like that. So I'm going to let you play with that if you so desire. It's up to you. Okay. All right, let's do this one. Okay, again, anything about multiplication or division has to come first. So what that means is I got to deal with this divided by 3. Where is that? It's inside the function. It's divided by 3. So that means since it's multiplication or division, it's either a stretch or a shrink. Because it's inside, you have to do the inverse, which means it's really going to be times 3, which makes things bigger, so that's a stretch. So it's inside, so it is a horizontal stretch of 3. This minus 2 is on the outside, so it's vertical, which means it's going to be and because it's addition or subtraction, it's going to be either a shift or move or whatever you want to call it. It's going to be something like that. Okay, so it's going to be a vertical shift. So that means up or down. And because it's minus 2, we are going to do what it says, because on the outside you do what it says. So this is down 2. Okay, so that's everything that happens to it. Let's start out with a parabola. Okay, so I'm following my normal points for a parabola. I'm going 1 to the left and 1 to the right, and I'm going up 1, and I'm going 2, up 4 from the vertex. Okay, the vertex is that corner-ish looking thing. Horizontal stretch of 3. All of my x values get multiplied by 3. This x value was 1, it's now 3. This x value up here was 2, it's now 6. This was 0, so this was 0, 0. 3 times 0 is 0. So it's going to still be 0, 0. It's exciting, isn't it? Negative 1 times 3, negative 2 times 3. Now, I'm thinking this is feeling like it's moving fast. Remember, you can pause, you can back up, you can do whatever you need to do because you are in control of the speed of this little dissertation here. Okay? And I know some of you will not sit and watch if I keep going on and on and on. All right, so why am I drawing this dotted? Because I'm not done. Remember that what I'm doing here is actually doing just the stretch. I'm not doing the shift yet. Okay, so I'm going to come now and I'm going to do, yeah, I should have done that graph in red. I'm sorry. That's just terrible. I wish I could just change it easily. Okay, so this one I'll do in blue. So now I need to shift down. Well, which graph am I shifting down? Ultimately, I need the shift and the stretch to both happen. So I'm really shifting the stretched version. So I'm going to shift down 2. So I'm going to go down 2. I'm going to take this point right here and I'm going to go down 2. I don't like that first one. Hang on. Let me back up a little bit. Love being able to just undo. Sorry, I know you can't do that in your notes. Green graph, down 2. Green graph, down 2. Green graph, down 2. Green graph, down 2. Something like that. Okay, and this is now done. Okay, so again, if you want to do a highlighter or something like that, oh, let's do purple this time. This will be so exciting. Okay, so the purple graph done. Okay, so let me clear the ink off of here again. Okay, and let's go y equals, and I just want to clarify again that that appeared to work. Okay, now, so we did, I need parentheses, and I did x over. Now, you can do alpha y equals if you're on a new system and make a fraction. So I can do x over 3. This is kind of sweet. I know it looks really good, doesn't it? Squared. And I believe, how did I miss? What happened? Well, hop on. What happened? There we go. Let's go 2. And then I believe it was down 2, minus 2. Okay, x over 3 squared minus 2. There it is. Okay, so the first graph, y equals x squared. And the next graph, horizontal stretch of 3 and shifted down 2. Kind of looks kind of sweet to me. I like it. Okay, so let's look at this. Oh yeah, that looks good. Look at that. That looks good. Okay. All right, well, we're going to leave it at that. So we've seen some examples of combinations when you have more than one thing going on at the same time. My advice to you is do anything stretch or shrink first. Once you've done the stretch or shrink first, then go back and take that image and shift it. If you have a combination of multiplication, multiplication and division, or addition and subtraction, do anything multiplication and division first. That's a stretch. Multiplication and division come before addition and subtraction, then do the other. It's a new record. I'm in under 20 minutes. Okay, not by much. All right, well, thanks for hanging with us. Again, remember, you can take breaks, you can stop, you can rewind, you can do what you need to do. Awesome. Talk to you later. SanfordFlipMath. Bye.